Alright, let's take a look at CCP 6.3. So, first of all, 1 and 2, that's something you guys can look up if you don't already know. So look it up, put it in your own words, and make sure you know that. Okay, now let's take a look at lines of symmetry and diagonals. So first we're going to start out with let's zoom in here. We're going to start out with lines of symmetry. So if we look at that, remember lines of symmetry are how we can fold it over. So for a triangle, if we go straight down the middle, we can fold that over. And since they're regular, when it says a regular polygon, it means all their sides are the same length and their angles are the same. Okay, so that would be another one. That would be a third one. So a triangle, there's 3. What about for a square? Well, a vertical, a horizontal, and also diagonals, huh? So there'd be 4. For a pentagon, 1, 2, 3, 4, 5. Okay, do we see a pattern here? For a hexagon, 1, 2, 3, 4, 5, 6. There would be 6. Okay, so I think it's pretty apparent that we have 7, 8, and so that would just be n. Okay, something else to notice for all the odds, they go from a vertex to a midpoint, whereas the evens are able to go vertex to vertex and midpoint to midpoint. Okay, so let's take a look now at the diagonals. So for the diagonals, remember they're a vertex to a vertex that's not already connected with the side. So a triangle, there's none of them. Okay, for a square, that vertex to that vertex, that to that one. So there'd be 2. Pentagon, 1 to there, 2, then we can do these ones, 1, 2, 1. So 1, 2, 3, 4. Wait, we can't count them twice, can we? So let's try that again. So 1, 2, 3, 4, 5. So 5. Okay, what about for a hexagon? 1, 2, 3, 4, 5, 6. Is that 7, 8, and 9. Right? Yeah. Okay. Because each of these vertexes have 3, right, that they're going to. And so there's 6 of them, so 6 times 3 would be 18, right? But since they go from one vertex to another, we have to cut them in half because we have to divide them by 2. We can only count them once. So let's try a heptagon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 7 and they each have 4, so 28 divided by 2, yeah, so 14. Okay, so 8 would be 1, 2, 3, 4, 5, 1, 2, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's see, so I'm not sure about that one. So we go 1, 2, 3, 4, 5. So each has 5. So 5 times 8 would give us 40. Cut in half would be 20. So I was 1 off. I must have forgotten one. Okay, so now what's the pattern there? How do we figure that out? Okay, well, how is this growing? Add 2, add 3, add 4, add 5, add 6. Alright. So that's not a linear and exponential pattern, is it? So we're going to have to think deeper. Well, could we figure out what 9 is? 9 would be 27, right? Because we'd add 7. 20 plus 7 would give us 27. So, well, let's think about what we did. We took the number of vertices, okay, in each shape, right? And so we had 3 vertices with 0 diagonals each. We had 4 vertices with 1 diagonal each. We had 5 vertices with 2 diagonals each. We had 6 with 3, 7 with 4. Do we see a better pattern here? 8 with 5. So the number of sides essentially minus 3, right? 8 minus 5 is 3, 7 minus 4 is 3, 6 minus 3 is 3, 5 minus 2 is 3. So we've got n minus 3. Okay, now what's that going to tell us? That'll tell us how many we get for each one, and then we multiply that by the number of sides, and then we divide all that by 2. So yeah, that's kind of crazy, isn't it? But let's check it with 9. 9 minus 3 times 9 over 2. 9 minus 3 is 6. 6 times 9 is 54. 54 divided by 2 is 27. Check it with number 5. Okay, 5 minus 2 is 3. 3 times 5 is 15, right? Oh, 2. N minus 3 is 2. 2 times 5 is 10. Cut in half is 5. Yep, there we go. That's your formula for it. Pretty crazy, huh? Alright, now we're still dealing with those lines of symmetry. So number 5, are all lines of symmetry also diagonals? Well, look at the square. Oh, and we went down. No, that and that are not diagonals, right? So no, because with even numbered sides, they can also have the midpoints, okay? Are all diagonals also lines of symmetry? This would be another no because of the odd, right? Because if I look down here, for the odd ones, that line right there is definitely not a line of symmetry, but it is a diagonal. Okay. What shapes will have diagonals that are not lines of symmetry? It would be the odd numbered sides. So just draw some of those. Number 8, will all parallelograms have diagonals that are lines of symmetry? Okay, in class I think we decided that with parallelograms. Okay, if you take a diagonal, it's not going to be a line of symmetry because this ends up coming over here. Okay, so that's kind of a drawing and an explanation. Number 9, what fraction of a turn does the model of a Ferris wheel below need to turn in order to appear the very same as it does now? So think of just one of these pieces. I just need to move it, basically one of those, for it to remain the same, right? Okay, when we rotated those shapes, that's kind of what we saw. So, how many degrees is that? Okay, what fraction? Well, that's 1 out of how many of these do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the fraction would be 1/18 of the circle. How many degrees would that be? Well, that whole thing is 360, right? And we're going to take an 18th of that, so whatever 360 divided by 18 is. So let me grab out my calculator, because that's one number that I don't know offhand. 360 divided by 18 is 20. So it'd be 20 degrees. Alright. Number 10. Find the angles of rotation that carry the 12-sided polygon below onto itself. So that's kind of similar to what we just did. So I'll let you guys do this one. Count the number of sides. Oh, we got on 12. Take 360, divide that into 12. That's going to tell you. Okay, so for number 11, you can figure that one out. Number 15, you can figure that one out. Okay. 13, now we're kind of going backwards. It says, how many sides does a regular polygon have that has an angle of rotation equal to 18 degrees? Okay. Well, how would I get 18 degrees? I'd have to go something divided by 18, right? Or 360 divided by the number of sides would equal 18. So how do I solve that? Well, it's an equation. Times both sides by n. So we get 360 equals 18 times n. Okay. Divide by 18, and that'll give us our answer, which I believe 360 divided by 18 should take us back to 20 sides. 20 sides. Okay. 14, how many sides does a regular polygon have that has an angle of rotation equal to 20 degrees? Okay. I want you guys to figure that one out on your own, which should be really easy with what we've done so far. Alright, now let's take a look at the go. Just to remind ourselves about some of these transformations. Okay, so number 9, reflect point A over the line of reflection and label the image A prime. So remember, when you're doing it over a line, what you have to think about is the distance you're traveling. Okay, so from the line to here, it's like we're traveling like that, right? But that distance is hard to figure out because coordinates work with vertical and horizontal lines. So figure out those differences and make a similar box. And at that corner should give you what you need. And that's not looking right to me, because I think I needed to apply it differently. Because this line's a little different, isn't it? I figured out why my first initial thinking wasn't working. It was because it made a rectangle, not a square. And we essentially need something that's more like a square to figure that out. So, let's take a look and think. Alright, so this gets really tricky. So, this is kind of the way to think about it. Okay, find some points on your graph. Here's a point, here's a point, here's a point, here's a point, here's a point. Okay, let's just pick this one. Why? I don't know. So let's find the slope from my point to this point. So it's, we go 1, 2, 3, 4, so up 4, and 1, 2 to the left 2. Right? So it'd be like 4 over 2. So we want to go to the left 2, or 4, 1, 2, 3, 4, and down 2, 1, 2. And that'll give us our point A prime. And that looks about right, doesn't it? Well, what if we went with a different point? What if we went down below? We'd go 1, 2, so we went down 2, to the right 1, 2, 3, or to the left 4. Okay? So we'd go the opposite. So instead of down 2, we go to the left 2, 1, 2. And instead of to the left 4, we go up 4, 1, 2, 3, 4. Okay. So it's kind of making a box. Now the weird thing is, this point right there is actually the same slope, up 1 to the left 3. We could go to the left 3 and up 1. We wouldn't go opposite. And I think it's because that one lies on the same line. So if we drew a line there, it would connect it. But that's how we go. Honestly, the easiest way to do this is to try to fold the paper. Because this other one, it doesn't seem to work the same way. And that's where I was struggling to figure out exactly what was going on here. These are difficult questions, and I've never really had to do it with this type of line. And even though it's a really difficult question, I won't give you ones like this on the test. Okay, so 1, 2, 3, 4, 5. So we went to the right 5 and then up 1, 2, 3, 4. Okay, so we would go to the right 4, 1, 2, 3, 4, and up 5. 1, 2, 3, 4, 5. Does that look right? It doesn't quite look right to me. And definitely going down wouldn't make it work. looks like to me like it should be somewhere in this area if I were to fold it over. So let me see if I can. I don't know what the difference would be if it's because we have this line is a negative slope instead of a positive slope. That negative slope means we have to do something differently. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. I don't know why I did that, but that looks a little better, doesn't it? Let me double check. Alright, so we should end up about 5, negative 1, right about there. Okay, right about there would be A prime. I don't know why I did a double prime. Okay. Now, the way that you figure that out, I'm trying to think of an easy way to explain that for you guys. Because these problems are difficult. They're even difficult for me. So don't, if you freaked out over this problem, realize it was a very difficult problem to figure out. And how we would go about, we could find our slope, which is down 4 to the right 1. So negative 4 over 1. And we could then find a slope perpendicular, which would be positive 1 over 4. So we go 1 up 1, 4. 1, 2, 3, 4 up 1. 1, 2, 3, 4 up 1. 1, 2, 3, 4. So it would, that would kind of get us to that same place, because that would work that way. But I don't want to freak you guys out with any more than that, so don't worry too much about 10. That was a tough one. And I don't know why it's not working the same way, but I think it has to do with that negative slope. So, sorry. Alright. Oh, great. Now we get to worry about these, huh? Of reflecting these over. These lines are a lot easier, though, I think. Especially this one, 12. Because notice how our slope is down 1 and to the right 1? I think that's a lot easier because if I move it over this way and down this way, I can do that same space and get a square out of there. So that's 1, 2, 3, 4, 5, 6, 7, 8. So we went down 8. 1, 2, 3, 4, 5, 6, 7, 8. To the left, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And that should 1, 2, 3, 4, 5, 6, 7, 8. So it's kind of like we made a box, and then that A prime would go right there. Well, and then we could kind of do the same thing with the other points, or just try to, base that idea. We go down and to the left. So reflecting that one over would be just like that. So it would end up right here for D prime. Okay, so this other one should end up right about there, B prime. Let's double check that. Going over here, going down here, yep. And C would go over right there, down to right there, so match it up on the other side. So it should look right like that. So kind of crazy how you figure that out. But see, on that, because the slope was a lot easier, that's why it worked so well. So I wonder this one if it has to do with that slope. Sorry, this one's really bothering me. I don't like when things bother me like that. So if I moved, let's see, that, but then going up would be I don't know where that would connect. Yeah, I'll have to ask another teacher that might know these better than I. Alright, for number 11, so let's see if we're going to have that same issue, aren't we? So its slope is going up 1 to the right 2. I don't know if that's important, but I'm putting it down. Okay, so if we started that same way, if we went up, this is going up 4. So I think that would go 8 over. So we wouldn't go to the left 8 and up. I wonder if we cut that in half and went 4, 1, 2, 3, 4, and up 1, 2. What do we think about that? Does that look? Point right there. To the right 2, down 3, to the left 2, up 3. I think that works. I think that slope must affect it like that. So if we look back at this one, if I could figure out what this number is here, and my slope being a negative 1/4, I would basically have to times it by a negative 1/4. So 1, 2, 3, 4, 5, 6. That would give me negative 6 over 4. So basically 3 halves, 1.5. No, that one's mystifying me. Makes me angry. And those are weird eyebrows. Anyway, alright. So now for that's B prime. So now that we go down and to the right, so we'd go up and to the left the same, right? That would be A prime. And then C, we go to the right 3 and down 2. So to the right 2 and up 3. Does that look right to me? No, that doesn't make sense, does it? I don't like that. I don't like trying to guess that way because my brain gets too mixed up. I can't visualize some of these moves too well. That's the basic shape. So we follow that along. These curved lines of reflection are a lot more difficult. Like this guy, not too bad. These other ones a lot more difficult. Yeah, okay. I had to look at the points to get my brain to mix with it. So we went to the right one here, so we go to the left one there. We went down 3, so we go up 3. So if we're trying to plot that C point, we go to the right 3, so to the right 3, and then down 2, no, to the right 2, and up 3. Alright, there we go. Alrighty, so there's those ones. Man, these were a lot tougher than I thought they'd be. I should have made those a little simpler for you guys. Alright, oh great. Now we get to draw the line of reflection. Okay, and for these ones, this is kind of what I'm looking for. Okay, connect those points as best you can. Okay, and then just think about where's, the midpoint of them. Okay, so I'm not looking for an exact line here. Just want you to draw what you think would be that best line. Don't try to do too hard, work it too hard. This one when they're not diagonal, it's pretty easy to see because you can count 1, 2, 3, 4, 5, 6, 7, 8. So half of 8 would be 4. So right here would be 4. Half of 4 is 2 right there. That one's pretty easy, right? You could draw that vertical line and see that it's not y, x. X equals -1 would give it to you. Whereas this other one, it's a diagonal. And I haven't dealt enough with diagonals to know the best way to go about doing that, other than just kind of eyeballing it, trying to cut it in half, and doing it that way. Okay. 15 says, using point P as a center of rotation, rotate point Q 120 degrees clockwise about point P and label the image Q. Alright, so this one, the way you're thinking about it, you're thinking of a circle, right? If that were my stick, and this was the end of the rope, and we ran around or played tetherball around it, that's what we're looking for. So we've got to figure out how far is 120 degrees. Okay, well, that's 90 degrees, 180, 270, and back around would be 360. So 90 is 30 degrees beyond that, right? Okay, so that's kind of where you're headed. And there's a few different ways that you could think to do this. Trying to think of what would be the easiest method to do that. So I would probably just kind of eyeball it. So I know I'm 1, 2, 3, 4 down. So if I went 90 degrees clockwise, Q would be right there, right? But we want to go a little beyond that. Okay, and if I were at 180, it would be right here. And so if we were halfway between, it'd be probably about right there-ish. Okay? So halfway between 90 is 45, so you're a little past that, so probably somewhere right there. So I'd label that Q prime. Oops, didn't want to erase it. There you go. So it doesn't have to be on a spot exactly. Okay, close enough that we get what's going on. Okay, 16 says using point C as a center and rotate R 270 counterclockwise. Okay, so this one's a lot easier because here's our center. So R counterclockwise is to the left. 90 would put us out here 3. Nope, just 3. 180 would put us down here 3, so 270 would put us over here 3. So that would be R. 90, 180, 270. Much easier, right? Alright, there you guys go. That homework took way too long. But I did a lot of the problems for you, so hopefully that made some sense, and I apologize for those difficult ones. Those were just kind of crazy, so I don't think we'll have some that difficult anymore. Alrighty.